How to determine the projection of a force. We'll see now the strategy and the steps that we must do in any time we want to find the components of any force, or even we can say any vector. So the steps are, the first step, we choose an axis of projection according to the component we need to find. So if you want to find, for example, the component fx, then I must choose the axis x-axis. If I want to find the components fy, then I want to choose the axis y. Second step, we notice the following cases. So we have many cases. First, if the force that we are finding the component is perpendicular to the axis we choose, then in this case its projection to this axis is 0. And we will see how to mean by this. Second, if the force is parallel to the axis, so we have two cases. First, it has same direction, it's parallel with the same direction, so its projection will be positive f. And if it's parallel but opposite direction, so its projection will be minus f. When I say its projection, this means, for example, f of x will be equal to minus f if I'm finding it along the x-axis. Third case, if f is making an angle alpha with the axis, so it's neither perpendicular nor parallel, then in this case I can't find the projection unless I draw it. I will trace, and then I must use sine alpha or cosine alpha to find it. So let's look closer to these three cases. First one, if f is perpendicular to the axis. So the question is, what is the projection of the force along the x-axis? We said that if f is perpendicular, then its projection is 0. This is our first case. Okay, how do we mean? What do we mean by this? So let's suppose, for example, we have this figure with some null forces. So we have, for example, these forces, the normal and the weight. And the question was, what is the projection of the forces along the x-axis? So first of all, I have the x-axis here. Okay, and then I must find the projection. So I look at the force. First step, I look at the force. For example, N is, with respect to the x-axis, it's perpendicular. So since it's perpendicular with respect to the x-axis, then directly its projection is 0. This means its component along x is 0. I look at the weight. The weight also is perpendicular to the x-axis. So in this case, if this is the weight, then also its projection is 0. This also means that the component along x is 0. Second case, if the force is parallel to the axis, also the question is to find the projection along of the forces along the x-axis. So is the candidate parallel to the axis? And two cases. حسب if same direction or opposite. Let's see the first one. Here, for example, if I want to trace the forces, مثلا, I have the tension force. I might have the frictional force. I have the weight and the normal. But if I want only to find the projection of the tension force. So if I want to look at the x-axis, this is the x-axis, the force with respect to this tension with respect to the x-axis is parallel, but it's not only parallel, it's parallel in same direction. Since it's parallel in same direction, then its projection will be plus f. So this means its projection, the projection of t will be plus t. Now, this means that tx is equal to plus t. What about now the frictional force? So if I want to look at the frictional force, f with respect to the x-axis, it's parallel, but parallel and opposite direction. So its projection will be minus f. This means the component x of this friction is minus f. Now the last case, what is the projection of the forces along the x-axis but when f is making an angle with respect to the axis? So let's suppose here we have this figure. I will take this force. I will call it the tension force and I will present it, simplify it. So in this case, if I want to find the projection along the x-axis of this force, first I will draw the x-axis. Second, I look at the force. It's not parallel to the x-axis nor perpendicular. Then in this case, I must trace the projection. So I will put the angle alpha here, and I will trace the projection. When I say tracing the projection, this means I do a perpendicular to the x-axis. I put the 90 degree. From the origin to the perpendicular, this will be the component Tx. So this is how we draw. This is the first step we draw. The second step, in order to find Tx, I must know, should I use sine alpha or cosine alpha? In order to know, I look at the component Tx. Is it adjacent to alpha or opposite? So we look, it's adjacent. If it's adjacent, then I know I will use cosine alpha. Since cosine alpha is equal to the adjacent over the hypotenuse, so adjacent over hypotenuse, and this means cosine alpha is equal to Tx over T, and this is how I can find then the component Tx, which is the projection of the tension along the x-axis. It will be equal to T cosine alpha. And I have the tension 150 Newton. I have the angle, which is equals to 60 degree. So the answer will be equal to 75 Newton. Now, let's suppose, for example, we want to continue this exercise, and I trace all the forces on this figure. So if I trace all the forces, I still have the normal, the friction, and the weight. So let's do it. With respect to the x-axis, n, the projection of n, is 0, since it's perpendicular to the x-axis. The projection of the weight is also 0, since it's perpendicular to the x-axis. But the projection of the friction will be minus f, since it's parallel to the x-axis but having opposite direction.